Hey everybody, I wanted to do just a few more examples of sketching rational functions. We only got to do one in class, and I thought it might be helpful to see a few extra. Just a disclaimer, I forgot my stylus at home, and I'm doing this at school on Friday afternoon because I'm really cool like that. And so the handwriting might be a little rough. Hopefully it'll still be legible. Let's suppose that I ask you to sketch f of x equals 3 minus 2x all divided by x minus 1. Now, one of the things we need to look out for is if we can factor this. Just glancing at it, I can tell the numerator, there's nothing I can factor on the numerator, and there's nothing I can factor on the denominator. So there's not going to be anything that crosses out. So that's neat. That's good. Let's determine the horizontal asymptote. So remember, horizontal asymptote is determined by the degrees of the numerator and the denominator, which in this case, the degree of the numerator is 1 and the degree of the denominator is 1. They're equal. That means we need to do a ratio. This one's kind of interesting because of the way it's written. My leading coefficients are actually -2 and 1. Your leading coefficients are whatever the coefficient is on the term with the highest degree. So my horizontal asymptote is going to be at -2 over 1, or just -2. So right away I know that I'm going to have a horizontal asymptote there. The vertical asymptote is determined by where the denominator equals 0. Since there was no factors that canceled out, it's not going to be a whole. So I know that where x equals 0 is going to be a vertical asymptote. Let's go ahead and write the domain, because when you're asked to do this on a test, you're probably going to be asked to state the domain as part of the question. So the domain of this is x such that x cannot be equal to 0. Other helpful points would probably be some intercepts, like a y-intercept or an x-intercept. Let's do the y-intercept first. Y-intercept is when you plug 0 into the function, like f of 0. That's going to be 3 minus 2 times 0 over 0 minus 1. So I have 3 over -1, so I have -3. My y-intercept is at 0, -3. And then I can figure out any zeros of the function by figuring out where the numerator equals 0. Sorry, I'm running out of space. Okay, x equals 3/2. So 3/2, comma 0 is another point. I have 2 points and I have 2 asymptotes. That's a really good place to start sketching. Okay, we should be ready to sketch this, and it's possible that we're going to need some additional points. I kind of want to graph what we have so far to see if we need any additional points. I determined that there was a horizontal asymptote at y equals -2. We can look back at our other page and see that when we did the ratio of the leading coefficients, we got y equals -2. And then I also had a vertical asymptote at x equals 1. Pretend that's going through the 1 there. And let's see, I found that there was a couple of things. There was a y-intercept at, let's use a different color. (0, -3) is where the y-intercept was. And then there was also an x-intercept too, which was, I think, at 3/2. 3/2 is 1 1/2, so it's kind of right there. That's not great. Now, just because I know what's happening with rational functions, I can kind of, I know what corners I'm in now, so that's good. It would probably be good to plug in another point somewhere over here. And that way I can exactly see that movement, and then also probably somewhere over here. I just like the lightsaber, let's be real. I'm going to plug in 3. Let's plug in 3 and see what we get. 3 minus 2 times 3 all over 3 minus 1. This will be 3 minus 6 will give me negative 3, and 3 minus 1 will give me 2. So negative 3 halves. So 3 is at negative 3 halves. That's down here. So that's good. I've kind of confirmed now it's going to go that way. Now let's plug in a point over on the left side, maybe like negative 3. It really doesn't matter where exactly or what the exact point is, as long as it's kind of in that interval. This is going to give me, I think, 12 on top, because I'll have 3 plus 9, and then a negative 4 on the bottom, so I'm going to have negative 3. So the point is negative 3, negative 3. Let's see if that makes sense. Negative 3, negative 3, that's like here. That looks great to me. There we go. Now we have a sketch. One thing that I have not done a great job of talking about in my class yet has been talking about end behavior. And there's actually 4 ends, and so we need to be careful. We need to talk about what's happening as x is going to infinity, like over here. That's as x is going to infinity. We have as x goes to negative infinity over here. And then we also have x as it approaches 1 from the left side, and x as it approaches 1 from the right side. So let's write what's happening here. There should be 4 phrases. As x approaches negative infinity, f of x is the y value, right? F of x is the y value. It's approaching this asymptote. So as x goes to negative infinity, f of x is approaching negative 2. Okay, there's one thing. The other thing on the left here is as x approaches 1. That's where my asymptote is. So notice my x is approaching 1, this line right here. My y is approaching negative infinity. So as x approaches 1 from the left, because I'm on the left side of the graph right now, it's approaching 1 from the left, f of x is approaching negative infinity. This tells me exactly what's happening with this graph. Okay, one more. As x approaches positive infinity, you'll notice the y value again is actually approaching negative 2. Oops, I did not write that correctly. I forgot the x, sorry, hold on. As x approaches positive infinity, f of x is approaching negative 2. And then we also need to take care of x approaching the asymptote from the right. So as x approaches 1 from the right side, f of x approaches positive infinity. So there is the end behavior. If you were asked to sketch the graph and then state the end behavior, this is what it would look like. For our next example, let's sketch f of x equals the quantity of x squared minus 4, all divided by the quantity of x squared minus x minus 6. Before I factor, let's go ahead and see what the horizontal asymptote is going to be. If I look at the numerator and the denominator, I see that they actually have the same degree. So the degree of the numerator equals the degree of the denominator, which means that it's going to be the ratio of the coefficients. technically there's a 1 in front of both of those. So my horizontal asymptote is going to be y equals 1. Let's go ahead and factor the numerator and the denominator. The numerator is going to be x minus 2, x plus 2. Denominator is going to be, we're looking at the negative 6, what multiplies to negative 6 and then adds to negative 1. That's going to be a negative 3 and a positive 2. Well, this is helpful because what we're actually going to be graphing and dealing with is going to look a lot more simple than what we started with. These factors cancel out. That tells me if I write the domain, x cannot be negative 2. Like that will cause a hole. So there's going to be a hole at x equals negative 2, which we are going to sketch. So you'll see what that looks like in a second. And then if I look at what's left in the denominator, I can see that x cannot be 3, that's going to cause an issue. So the vertical asymptote is going to happen where x equals 3. And then there's a hole at x equals negative 2. Let's figure out some points here. The thing that's kind of nice about having the simplified rational function is that we can actually just use it to find points. So you'll notice that I guess I could use the whole thing, but this is going to be a lot more simple if I just focus on this part of the function, just the simplified part, because the other factors are going to cancel out regardless. The y-intercept is going to happen where x equals 0. I can see that that's going to be 2/3. So I'm going to have the point 0, 2/3. That's one of the things that I'm going to use to graph. Now the x-intercept is where the y equals 0, which is the function, right, where f of x equals 0. And really what's going to cause that to equal 0 is where the numerator equals 0. Again, I only need to focus on the part that is simplified because the x plus 2 cancels out, and besides, if x was negative 2, it would cause the function to be undefined. That would not be a 0. So I'm going to solve this, and I see that x equals 2 when y is 0. So there's another point that I can use. I have an x-intercept, I have a y-intercept, a hole, a vertical asymptote, and a horizontal asymptote. With all these things combined, I will have a pretty good sketch once I add a couple more points in. So let's do that on the next slide. I'm going to go ahead and put all the things that I know about this function onto this graph. My original function was this, and then we actually simplified it to this. And I should use f of x. I'm not sure why I'm writing y, but you get the idea. Okay, so it's interesting because in graphing that first function, it's actually going to look like the second function. It's going to look like the second function, but it's going to have a hole. All right, the things that I know are the horizontal asymptote is at y equals 1. I'll try to put that on the 1 as close to as much as I can. Okay, so there's the horizontal asymptote at y equals 1. I know that there is a vertical asymptote at x equals 3. All right. I also know that there's going to be a hole at x equals negative 2, but in order to figure out what that value is, obviously I can't just plug negative 2 in. It's going to be undefined. So what I will do instead is kind of find some points around that value. Let me graph the points that I know. We know that there is a y-intercept at 0, 2/3. Okay, there about. And I know that there is an x-intercept at 2, 0. Well, this is kind of interesting because really it just gave me 2 points that are kind of in this quadrant, if you will, of the rational function. I can kind of tell just from these 2 points that the function's going to be doing this. But one thing that's interesting is right here, I need to draw a hole. It's a little hard to do it on here very accurately, but that's going to actually be like a curve, like a normal curve, but then there's going to be a hole right above x equals -2 because that's the factor that had canceled out. I can assume that the other is going to look something like this up here, but really we should plug some extra points in up here just to be sure. Might be a good idea to plug in x equals 4, for example. Let's try that and then see what that gives us and then go from there. Another thing that's nice about having the simplified function is I can actually plug my points into here instead of into here, just because they are going to give you the same answer, because that factor is going to cancel out on the top and bottom. It's going to be the same thing. If you wanted to prove it, you totally could. Like, for example, if you plug 4 into the top equation, you end up getting 12/6. And so you'll get 2. And if I plug 4 into this equation, I have 4 minus 2 over 4 minus 3, and I get 2/1. So I get 2. So 4 comma 2 is going to be a point. Let's graph that. I'm kind of tempted to maybe plug in like 6 or something. Let's plug in 6. We can plug it into the simplified equation just to make our math a little bit easier. 6 minus 2 over 6 minus 3. We get 4/3. So the point is 6 comma 4/3. 4/3 is 1 and 1/3. So at 6, I have 1 and 1/3. It's kind of down here. Just to be absolutely sure, I could plug in a point in between 4 and the vertical asymptote. I don't know that you would necessarily need to do that, but let's say I plug in 3.5. 3.5 minus 2 divided by 3.5 minus 3. 1.5 divided by 0.5. That's the same thing as saying 1.5 divided by a half, which is the same thing as saying 1.5 times 2. If you multiply the reciprocal, we get 3. So 3.5 comma 3 is a point. 3.53 is about here. That's what we would expect it to be. That's great. Now we have a pretty accurate sketch of our picture. There it is. Let's discuss our end behavior. I'm going to do that in this top left-hand corner of the graph. Just for practice here. So again, when we do end behavior, there's 4 parts to it. There's x as it approaches negative infinity this way, and x as it approaches positive infinity this way. And then we also have this vertical asymptote. So we need to talk about x as it approaches the vertical asymptote from the left side, and x as it approaches the vertical asymptote from the right side. So let's do all the things on the left first. As x approaches negative infinity, okay, so that's here, what is the function value doing? The function value is approaching 1. You know, this line right here is y equals 1. So as x goes to negative infinity, f of x is approaching 1. All right? And then as x approaches, now my vertical asymptote is at x equals 3. So as x approaches 3 from the left side, f of x is approaching negative infinity. I'm going to show that with a pointer in just a second. Okay. Here we go. As x is approaching 3, so here's where x is 3. So x is approaching 3 from the left side. That's what the little minus means. My y is actually approaching negative infinity. As x approaches 3 from the left side, y is approaching negative infinity. As x, now that's all the things on the left side. Let's look at the right side now. As x approaches positive infinity, my y value, my f of x, is approaching 1. As x is approaching positive infinity, f of x is approaching 1 yet again. This makes sense because it's a horizontal asymptote. The horizontal asymptote is always what the function is going to be approaching as x goes to infinity and negative infinity. Then I also need to talk about the vertical asymptote again, but this time it's going to be approaching 3 from the right side, so I put a little plus sign. As x is approaching 3 from the right side, notice it's coming from the right, it's approaching 3 right here, the function value is going to positive infinity. Okay, so there is the end behavior. On a test, you would be expected to, like this kind of encompasses levels 1 through 3 right here. Finding the asymptotes, finding the end behavior, and being able to sketch, that's kind of all levels 1 through 3 there. We're also going to be talking about something called a slant asymptote on Tuesday, and that's going to be more of a level 4 question when you have a slant asymptote. But this is really key. All of the things that are here, this is levels 1 through 3. We will have a test on Friday of next week, so please make sure to do the practice for this that I assigned on Friday. I hope you guys have a great long weekend, and I will see you on Tuesday. Try to stay warm.